This problem has two parametric equations. I want to graph them using table values. After that, I want to convert the parametric equations to rectangular equations. So let's go. Number one, we have x equals to t to the third, y equals to t plus 2, where the t is between those two values. So first of all, we have to plug in each of these t values to the parametric equation. So starting with t equals to -3. So when t is equals to -3, we have x equals to -3 square minus 3, that equals to 6. And then y is equals to 3 plus 2 equals to, forgot the square, -3 square plus 2. Looking at the wrong place. T is just equals to -3 plus 2. Talking too fast. So y is equals to -3 plus 2. That is equals to -1. So we have a 6 -1. And then, so let's write the point x comma y equals to 6 comma -1. When t is equals to -1, we have x equals to -1 square minus 3, that equals to -2. Y is equals to -1 plus 2 equals to 1, so -2, 1, -2 comma 1. And then t equals to 0, we have x equals to 0 square minus 3, so we have a -3, and then y equals to 0 plus 2 equals to 2, so we have -3 comma 2, so this is a negative. This will be a -3 comma 2 when x is equals to 1. So x is equals to 1. I mean t is equals to 1. We have x equals to 1 square minus 3. That equals to -2. Y is equals to 1 plus 2 equals to 3. So we have -2 comma 3. And then the last one, when t is equals to 3, we have x equals to 3 square minus 3, 6. Y is equals to 3 plus 2 equals to 5. So we have a 6 comma 5. 6, 5. So let's plot them in this order. So the first one, the second one, the third one, the fourth one is -2, 3. And then the last one is 6, 5. So let's do the plotting. 6, -1. So 6, -1 is right here. And then -2 comma 1. And then -3 comma 2. And then -2 comma 3. And then 6 comma 5. So we remember the order is what the order is, right? So the dot stands for a particle. So we have a particle or an object starting at 6, -1, and then we move to this point, and then we make a turn, and then we go to this point, and then the orientation, which the direction is this way. So that is the orientation. And what is this graph called? This graph is called a parametric. This is called a parametric curve. The graph of the given parametric equation. So what is the concept behind this? So when I give you a rectangular coordinate, so let's say x comma y is equals to 6 comma 5. So this tells you where the particle is. Okay, so when x is equals to 6, y equals to 5, you look at the graph, you can see where the particle is, but it doesn't tell you when. So when the time is equals to 3, I know the location of the particle is 6 comma 5. This answers the question when, because if you just look at the y equals to some x or x equals to some y, you only see location. There is no time, because the particle is travel on this path. We do need to know the time. In order to find out the time, we have to use parametric equation. The time t is my parameter. We are going to link the parameter into multiple equations. So that is not the end of this problem. So we have a parametric equation. I want to convert the parametric to rectangular. All right, so let's do that. Let's do this in another color. Let's do this in a pink. So what is my parametric equation? I have x equals to t squared minus 3. So t squared minus 3. And y is equals to t plus 2. So first, let's rewrite the t. So the t, that is the same thing as t equals to y minus 2. So now t stands on one side. I will plug in the y minus 2 to this t. So the x becomes x equals to t squared minus 3. So that will be a y minus 2. So you expand that. X is equals to y squared minus 2. 2y minus 2y is 4y. And then plus 2 times 2 is 4. 4 minus 3 is positive 1. So this is my rectangular equation. And y is between where and where? Y is between where and where? Check out the table. Y is between here, -1 and positive 5. All right, so y is between -1 and positive 5. What is the graph look like? Do you still remember the graph of this? Y equals to x squared. I should use another color because that is like a side note, right? So I should use another color. So let's use a white. So we have a y equals to x squared. This is a parabola, right? So how about the inverse function? X equals to y squared. So that will be this. It's not really an inverse function. X equals to y squared. So that is a sideways parabola, and the mouth of this parabola is facing the right. So since you have y squared minus 4y plus 1, that means based on this parabola, you have to make some transformation, right? So the graph of y squared minus 4y plus 1 is this. So the graph looks like that. It's a sideways parabola. The vertex is at -3, 2. So when x equals to -3, y equals to 2, here is the vertex, and the graph looks like this. So this is the graph of x equals to y squared minus 4y plus 1. So this is the relationship. This equation explains the relationship between x and y. So when x equals to a value, y equals to a value, you only see the location. There is no time t. So in order to use the time t, you have to use a parametric equation and a parametric graph and a parametric curve. All right, so that would be the first one. The next one, I would like to work with some trigonometry. So this is the next one. So that is problem 2. So problem 2, I already set up the table for you. So let's start with t equals to 0. So when t is equals to 0, we have x equals to sine of 0. Sine of 0 is equals to 0. And then y is equals to 1 minus cosine 0, which is 1 minus 1. That is equals to 0. So the first point is 0, 0. And then when t is equals to pi over 2, we have x equals to sine of pi over 2. Sine of pi over 2, don't think about calculator. Sine of pi over 2, you should know what it is. We calling the unit circle. Sine of pi over 2, the y coordinate is equal to 1, right? This should not be the calculator problem. And then y is equals to 1 minus cosine pi over 2, 90-degree counterclockwise. The point is, the destination is on the y-axis between quadrant 1 and quadrant 2. So at that point, x is equals to 0. 1 minus 0 is equals to 1. So this is 1, 1. And then when t is equals to pi, you have x equals to sine of pi 180 degree, y is equals to 0. Y equals to 1 minus cosine pi 180 degree, y is equals to -1. So you have 1 minus -1. That equals to 2, then you have a 0, 2. And then 3 pi over 2, 270 degree. So t is 3 pi over 2. Then x is equals to sine of 3 pi over 2, 270 degree counterclockwise. You are on the y-axis between quadrant 3 and quadrant 4. So at that point, y is equal to -1. and then y equals to 1 minus cosine 3 pi over 2. So at the y-axis, x is 0, 1 minus 0 is equals to 1. So you have negative 1 comma 1, negative 1 comma 1, and then the last one is 2 pi. X is equals to sine of 2 pi. So that is the same as sine of 0, that y coordinate is equals to 0. And then y is equals to 1 minus cosine 2 pi. So at that point, cosine of 2 pi, so we back to the 0, right? So that will be a 1 minus x equals to 1, that equals to 0. So the last point is 0 comma 0. So 0 comma 0. So now we got all the x and y coordinate. So this is the first point, second point, the third point, the fourth point, and the fifth point. We have to go by this order. And then for the t value, so let's say you are doing a homework problem, you have to set up this table yourself. Make sure the t is in ascending order because we need the correct orientation. I need to know the correct path of the particle, which direction is the particle moving. I need to know the direction, which is called orientation. So t must be in ascending order from the smallest possible t to the largest possible t in the interval. All right. So the first point is 0, 0, which is right here, right? So 0, 0. And then the next point is 1, 1, 0, 2. Oh, easy, negative 1, 1, and then back to 0, 0. So that means the particle is traveling on this circle, so moving to this direction. So that is the path of the direction where the particle is traveling. So what is the difference between what is the difference between parametric curve and a rectangular curve? This is a parametric curve. So parametric equation, you use one parameter t to link multiple functions, right? So you have x equals to some t, y equals to some t. Okay, so in this problem, the 1 comma 1, the 1 comma 1 that is equals to x comma y, right? That's how we found the point. The 1 comma 1 tells you a location. Location in math means where. It doesn't tell me when. It doesn't tell me when. So to find out the when, the time, I have to let t equals to something. So when t is equals to pi over 2, at that time, I know exactly where the particle is. So when time is equal to 1, I know the location of the particle is at 1, 1. So if you cover up the time, you cover up the parametric equation, you only get the location. There is no, if you want to find time, you can't do it because there is no t. In rectangular, you only have x and y. So now is the time to put this parametric to rectangular. I'm going to do this in another color. So we start with parametric. X is equals to sine of t. Y is equals to 1 minus cosine of t. We are trying to change this to, not change, convert this to a rectangular. So okay, this one is a little bit more difficult. So how about this? I would like to square both sides. So x squared equals to sine square t. And then the y, I would like to do this. Y minus 1 equals to negative cosine t. And then square both sides. Y minus 1 square equals to the square of negative. So that becomes cosine t squared, or you put the square right here, right? And then I will add the sine t and I add the sine square t and the cosine square t here. This is the sine square t. This is the cosine square t. So here is what I am going to do. I am going to do sine square t plus cosine square t. What is the parametric curve looks like? That looks like a circle. So that means at the end of the day, we will get an equation of the circle. So sine square t is x squared, and then the plus is a plus, cosine t is y minus 1 squared. I know you are wondering how, like in the middle of the test, how do you figure out that this is the correct path to go? Look at the graph. The graph is a circle, right? So that means we will get an equation of a circle. Regarding the equation of a circle, you learn that in pre-calculus. Equation of a circle that is called a conic section. Conic section. You learn that in the conic section. Remember that equation of a circle, ellipse, hyperbola, and parabola. If you don't remember that, go take a look. So that is the equation of a circle. So what is sine square plus cosine square looks equal to? Do you still remember your trigonometry? The trig fundamental identity, sine square x plus cosine square x is equal to 1, right? So this is 1, and then on the other side, instead of writing x square, you have x minus 0 square plus y minus 1 square, and then the 1 is the same thing as 1 square. So this thing overall is equation of a circle. So what is the standard form? The standard form is x minus h square plus y minus k square, I'm reviewing that for you, equals to r square, and the center is h comma k, and then the radius is equals to r. So since this one, where is the center? The center is 0 comma 1, right? And then the radius is equals to 1. So that is pretty easy. 0, 1, right? So 0, 1 is 1 point, is 1 step above the origin, and then you have a radius 1, radius 1, radius 1, and then radius 1, and then you sketch your circle. So this is the graph of this equation of a circle. So when x is equals to 0, y is equals to 2. So this is a xy coordinate. You don't know the time. So this one has no orientation, no direction. You don't know the time because this is a rectangular equation. This is a rectangular equation. You don't know the time. All right, so that will be the end of this problem. If you think my instruction is helpful, do 3 things for me: subscribe, share, and like. I appreciate your help, of course. I see you all in the next lesson. Signing out for now.